Hey guys, welcome to Data Academy. My name's Oliver. Last week we learned about data types. Today we're going to look at data structures. A data structure is a way for us to efficiently organize data types so we can work on them. And we're going to learn about sequences. Inside sequences we have lists and tuples. They are both ordered and duplicates are allowed. So let's take a closer look in Python. I've just created my very first list in Python. To create a list, you want to use square brackets and you want to separate all the elements inside with commas. And you can have more than one type of data inside. So it can be strings, integers, floats, booleans, or even a list all combined. We'll take a look at that later. So to index lists, we're going to use square brackets, and if I want the first item in it, we're going to use 0, and I get apple. Now let me show you something interesting about indices. Alright, so we've always learned that this is the 0th index, this is the first, second, and the third. Now when you start doing more advanced things with lists and data structures, there's a good way to think of indices where the spaces between them are actually your indices rather than your actual elements. So before your first element, that's going to be your 0 and 1 and 2, 3, and 4. Now, if we want to select a range for an index, then we can say index 2 through 4. Or we could say, if we want the middle two elements, we could say index 1 through 3, and that would select a certain range of them. Okay, back to Python. Like I said before, what if we wanted to select the middle two elements? Then I could also index them by using index 1 until 3, and we separate these with a colon, and it's going to give me banana and orange. If we leave out one of the numbers, if we leave out the first number, it's going to assume we're starting from the beginning. And let's say I want the first two elements. Then I'm just going to go up to index number 2. And if I leave out the last number, it's going to assume we want to end at the end. So if I wanted the last 3, then I would be starting at index 1 until the end. And I'd be getting banana, orange, and mango. Now let's look at some basic operations on lists. How do we add an element to the end of our list? We're going to use the .append function. The parameter of the function will just be what we want to add. Now if we call fruits, we can see watermelons at the end. We can also use the .insert function to add an element to the middle of our list. So let's say we want to add it right in the middle between banana and orange. Like the index method I showed you before, that would be index number 2. So we're going to put this in index number 2 by first saying the index, comma, and then we're going to add our object. Now if we call fruits, kiwi is between banana and orange. We know how to add things to our lists. What if we want to remove them? We can use the .pop function, and if we don't write anything within the parentheses, then it's just going to remove the very last item in our list. In this case, it was watermelon, and it told us what that element was. It says watermelon right there. If we call fruits, we can see that watermelon is no longer at the end. Alternatively, if you know which index something is at and you want to remove that index specifically, we can use .pop. But in our parentheses, we type what the index is. If I wanted to remove kiwi, I know that's index number 2, and now it's telling me it removed kiwi. Alternatively, once again, we could also remove something based on the value of it. So I would be using the .remove function, and I just type in, let's say I wanted to remove orange, I would type that in. And if we call fruits, orange is no longer there. Now keep in mind that this will only work on the first instance of something. So if it said orange twice, it would only remove the very first appearance of it. We can test membership of an element within a list by typing the value of the element and then saying in name of the list, that's true. we just removed orange. So let's see if that's in our list. No, it's not. Okay, like I said before, we can have lists as an element of a list. So the way we do that is, first I have two lists, one containing numbers, the other containing fruits. And I'm gonna create a new list called my list, and inside we're gonna have our numbers list and then fruits. Now once I call my list, you can see that we have a nested list, which is a list within a list. Now how do we refer to each element within our nested list? Let's say I wanted to refer to this number 2 right here. Well, let's think of this entire list as an element. So that would be the very first element, which is the 0 with index. And then 2 would be the second element, which is the first index. And now that's going to give me 2. Same thing with the second one. If I wanted apple, then I would be getting the second element, which is index 1, and then the 0 with index, which is the first element, and that is apple. Now, tuples. We saw that we use square brackets to create a list. I just created a tuple called fruits, and we use parentheses instead of square brackets. The difference between lists and tuples is that I can only create a tuple. I can't add items. I can't remove items from it now. Now you might ask, why is this useful? Well, there's lots of use cases of tuples. The one that comes to my head right away is it could be used as a key for a dictionary. We're going to learn about dictionaries in a later lesson, so stay tuned for that. But we can index a tuple the exact same way that we can index a list. So the third element in our tuple fruits is orange, just like a list. But what if we try and append something to the end? It's going to give us an error message. Tuple object has no attribute append, because we cannot change a tuple. It is immutable. That's what it means to be immutable. A list is mutable because we can add things, we can remove things to it, but we can't do that to a tuple, and that's why we call it immutable. Well, thanks for watching this video on the sequence category of Python data structures. See you all next time.